Today we'll be looking at Lesson 3, Equivalent Ratios. Before we get started, let's think back and remember what we learned about ratios. Remember, a ratio is a mathematical way of showing a relationship between two values. To begin today, let's start by writing a one-sentence story problem about a ratio. Let's make our story problem about the word ratio. So let's think about the letters in the word ratio. There are 5 letters, but there are 2 different types, consonants and vowels. So let's think, what story problem could we write about the word ratio? Well, we know that there are 2 different types of letters in the word ratio. They're vowels and consonants. So our word problem could be, what is the ratio of consonants to vowels in the word ratio? So that is our word problem about the word ratio. It's comparing or showing the relationship between 2 values, the value of consonants and the value of vowels. So now let's write our ratio. Okay, to write our ratio, we first need to figure out how many consonants and how many vowels are there. So looking at the word ratio, there are 2 consonants and 3 vowels. So we're going to write our ratio in 2 different ways. The first way we're going to write our ratio is with a colon in between. So we're going to take the 2 from the consonants and put a colon or 2 dots on top of each other, and then the 3. So this shows our ratio of 2 to 3. The second way we can do it is by putting the word 2 between it. Just like I read last time, we can just write the word 2 instead. So I could write 2 to 3. It's important that we remember to always make sure we keep our numbers in the same order or the order in which they are written in the word problem. Our second exercise is about Shani and Mel. Shani and Mel are using ribbon to decorate a project in their art class. The ratio of length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. Let's start by representing this ratio in a table. To create our table, we're first just going to make a simple T-chart. On one side, we're going to put Shani, and on the other side, we're going to put Mel. Well, to make our ratio table, all we're going to do is start with what is the length for Shani, and for Shani it is 7. Then what is the corresponding length for Mel? That is 3. So we put those across from each other. Then we can put a line to separate our next step in our ratio table. Well, all we're going to do is we can just double each number. So Shani's number from 7 is going to become 14. And Mel's number from 3 is going to become 6. And let's do one more round. So again, all we're going to do is this time instead of doubling, we're just going to add another 7. So each time we're counting up by 7, or using the multiples of 7. So 7 more than 14 is 21, and 3 more than 6 is 9. So there we have a ratio table representing the ratio of ribbon from Shani to Mel. Well, now let's do what the exercise is asking us to do. Let's draw a tape diagram of this ratio. Now, to draw a tape diagram, we're basically going to draw 2 strips or tapes that each are proportional and represent the length that is shown in the problem of 7 and 3. So let's start by making Shani's. Well, how long should Shani's be? Shani should be 7 long because her name comes first, so her name comes first in the ratio. So Shani's needs to be 7 long, so I can just make 7 boxes long. 1, 2, 3, 4, 5, 6, 7. And now we can start with Mel's. Mel's, we're going to do the same thing, except this time I'm making it 7 long. Mel's is going to be 3 long. So all I need to do is make a box 3 long. This is a nice visual way to see the comparison of 7 to 3 for Shawnee and Mel. Well, now let's start to think about what each of these numbers represents. What unit is represented by each length for Shawnee and Mel? Well, we can't tell yet. The ratio doesn't tell us the units, it just tells us comparison between Shawnee and Mel. But what if we were told that each tape diagram, each section represents 1 inch? Well, then Shawnee would have 7 inches and Mel would have 3 inches, because each section would be 1 inch. 1 inch, 1 inch, 1 inch, 1 inch, 1 inch, 1 inch, and 1 inch for 7 inches. But this can change. What happens if we instead say that each one is 2 meters? Well, then instead it would be 2, 2, 2, 2, 2, 2, and 2 for 14 meters. Where each one represents 2. Then Mel's would be 6 meters. So you can see the ratio doesn't tell us the actual unit, but it shows a comparison. You can see this in our ratio table that we made in the beginning. Here you can see the 7 to 3 if represented by 1 unit, but if each one represents 2 units, then here you can see the 14 to 6. Now, some people would still say that this ratio, if it was 2 units for 14 and 6, would still be 7 to 3. Well, you can see they're equal ratios or equivalent ratios. They're just reduced, just like you can do with fractions. And we'll get more into that a little later. Now, what happens if we would say each section would represent 3 inches? How long would you say Shawnee's ribbon is and Mel's ribbon? I'll give you a second to think about it yourself. Well, did you get for Shawnee's ribbon that it would be 21 inches and Mel's ribbon it would be 9 inches? Because again, it would be 3 for each section, and as for Mel, it'd be 3, 3, and 3, 3, 6, 9, or 9 inches altogether, which you can see down here on our bottom section of our ratio table. So we have just explored 3 different possibilities for lengths of each ribbon for Shawnee and Mel. And every time we explored it, the length of each ribbon changed, but the number of sections in each ribbon did not. That's because the comparison between the two was the same. The relationship between Shawnee's ribbon and Mel's ribbon was the same. They may have gotten longer, but they both got longer together. So we came up with 3 different ratios. We had 21 to 9, 14 to 6, and 7 to 3. All 3 ratios worked with the same ribbons. These all 3 ratios are special ratios called equivalent ratios, meaning that they can be represented by the same ribbon or have the same value. Okay, let's look at another situation and explore this a little bit more. Mason and Laney ran laps for a long-distance running team. The ratio of number of laps Mason ran to the number of laps Laney ran was 2 to 3. If Mason ran 4 miles, how far did Laney run? Draw a tape diagram to demonstrate how you found the answer. So let's start with our tape diagram. For our tape diagram, we need to first look at the ratio. The ratio is 2 to 3. So we'll start with Mason, because again, Mason was listed first in the problem. So Mason, well, his tape diagram should be too long, because Mason's part of the ratio is 2. Then we go to Laney, and Laney's is 3. So we draw Laney's tape diagram 3 long. Now, if Mason ran 4 miles, how far did Laney run? Well, now we got to figure out what numbers do we place inside those boxes to make Mason have 4 miles. Well, if we put 2 miles in each box, that'll give us a total of 4 miles. So if I put 2 and 2 here, Mason will have run 4 miles. Well, if I put 2 in the boxes for Mason, to make it an equivalent or equal ratio, we need to put 2's in the boxes for Laney. So I put 2, 2, and 2. So Laney then has 6 miles. So Laney must have ran 6 miles. Well, let's look at it another way. If Laney ran 930 meters, how far did Mason run? Draw a tape diagram to determine how you found your answer. Well, we can actually start with the exact same tape diagram. Mason would still have 2. Laney would still have 3. This is because it's still going to be an equivalent ratio. Now, we just need to figure out how many meters would Laney have to run in each of her sections. So we need to figure out how much would each section be to total up to 930. Well, to do that, we would need to split her 930 into 3 even pieces. So we can take 930 and divide it by 3 to split into 3 even pieces. And 930 divided by 3 is 310. So each little box or each little section is going to be 310. So 310, 310, 310 gives me the 930. Since Laney went 310 in each section, Mason's going to have to do the same thing. So I write 310, 310, and that totals up to 620 meters. So what ratios can we say are equivalent to 2 to 3? Well, we can look back to our first situation where we learned that Mason ran 4 miles. Well, our equivalent ratio could be 4 to 6. There, our units were 2 miles. Or instead, what we could do is we could have the equivalent ratio of 620 to 930. There, each section or each piece was 310 meters. So we could write our ratios as 4 to 6, or 620 to 930. There's 2 other equivalent ratios for 2 to 3. We're looking at one more situation with equivalent ratios. In this situation, we're looking at Josie, who took a long multiple choice test for the end of the year vocabulary test. The ratio of number of problems Josie got incorrect to the number of problems Josie got correct was 2 to 9. So if Josie missed 8 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found your answer. Well, we're going to draw another tape diagram. And for our tape diagram, we're going to draw our 2 tapes. Our first tape is going to be our incorrect, because again, that's what came first, is the first number in our ratio. I am just going to use I to represent incorrect to save ourselves some time. And so for incorrect, it needs to be too long. So I draw my tape too long, because again, our ratio here said 2 for incorrect. For the correct, it says 9. And so I'm just going to use a C to represent correct, and then draw my tape 9 long. And I have 1, 2, 3, 4, 5, 6, 7, 8. To add one more on for 9. There we go. We have our 9. Now, if Josie missed 8 questions, how many did she correct? Well, we have 2 boxes in our tape for the 8 questions. So how much would each box be? Well, that must mean there is 4 in each box, giving us the 8 questions she missed or got wrong. Well, that means then that we need to have 4 in each of our boxes on the bottom. And since there's 9, it's going to be 4 times 9. And we then will get 36. Correct. So she would have gotten 36 correct. Because it would be 4 times 9, since there's 4 for each section of the tape diagram. Well, what happens, and B, let's see what happens there. If Josie missed 20 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. So again, we're going to use I for incorrect and start our tape diagram with 2 boxes. And then C for correct and start our tape diagram with 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Add one more again, 9. And now, this time, she missed 20. Well, how much is going to be each box then? Then each one's going to have to be 10. And that's going to get us our 20. Well, if we have 10 in our boxes above, we have to have 10 in our boxes below. So then we're going to do 10 times 9 to get our 90. So she would have gotten 90 correct. Okay, so that leaves us down with one more question here. What ratio can we say are equivalent to 2 to 9? Well, we came up with 2 different ones. We have 8 to 36 and 20 to 90. So we can write that as 8 to 36 and 20 to 90. These are equivalent ratios because they represent the same tape diagram of 2 to 9. Okay, let's look at 3 last questions about Josie's situation and equivalent ratios. The first question, come up with another possible ratio for the number of Josie got incorrect to the number she got correct. So let's remember that our original ratio was 2 to 9. 2 incorrect to 9 correct. So let's start off again by making our tape diagram. 2 in the top box for the 2 incorrect, and then 9 in the bottom box. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then all we have to do is pick a new number to go inside the boxes. On the previous page, they gave us numbers we put in, like 10 and 4. So let's pick our own. I'm going to pick 5 because 5 is a nice easy number to work with. So I'm just going to put 5 in every box. And then we can see what our new ratio is. On the top box, there's 5 and 5, which is 10. So she got 10 incorrect. But on the bottom box, there's 9 5s, or 9 times 5, which is 45. So our new ratio is 10 to 45. You could have picked any number to go inside the box. As long as you put the same number in all the boxes on the top and the bottom, you would have gotten an equivalent ratio, or a ratio that would have worked. So let's look at the next question. How did you find the numbers? Well, all we did was we picked a new number, here 5, and we multiplied it. See how we did 9 times 5? Times the original ratio. So 2 times the 5 got us 10, or 9 times the 5 got us 45. So how did we figure that out? We multiplied the same number by both numbers in the ratio. There we go. So that's what we can do. You can multiply any number times each of those numbers in the original ratio, and you'll get an equivalent fraction. So describe how to create an equivalent ratio. Well, what will we do? We will multiply or divide both numbers. Spelled divide wrong. But divide both numbers by the same number. And there we go. That is how we can create an equivalent ratio.